Hi everyone, welcome back. Today we're solving minimum cost path with edge reversals. So we will be given an array of edges. It will list the node that can travel to another node and it will take up a certain amount of weight. So UVW from node U to node V with a cost of W. And we can actually travel reversely. So let's say right here, we can actually travel back, but it will cost 2 times the weight to travel backwards. And we want to return the minimum cost it takes to go from node 0 to node n-1. And if it is not possible, then we will return -1. So if we look at this example, we will start on node 0 and n is equal to 4. So n-1 is 3 and we want to find the shortest distance to node 3. And as we can see, the shortest distance will be 5 because this to here would be a distance of 3. And this to here, we can travel backwards. 1 times 2 is 2, 3 times 2 is 5. So we can have a distance of 5. And right here, the minimum distance would be 3 because we start on node 0 to 2. It can have a distance of 1. And from node 2, we can travel to node 1 with a distance of 1. And we can go from node 1 to node 3 with a distance of 1. And that will add up to a distance of 3. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we can use the Dijkstra algorithm. So first, we will need to create a default dictionary for the edges. And there will be 2 types of keys. The first key would be node U, and that is to calculate the distance it takes to get to node V. So the key will be U, and the value would be a tuple of V and the cost it takes. And when the key is V, the value would be node U and the cost it takes to get to node V, and that would be 2 times the cost because we are traveling backwards. And now we also want to create a set to keep track of the nodes that have been visited when we are traversing later because we want to avoid revisiting a node. And now we want to initialize a heap of 0, 0. The first 0 will represent the current distance and the second 0 will represent the current node. And we always start at node 0, and when we start, we have not traveled any distance, so the distance would be 0. And now we want to continue to pop and add to the heap. So we will always pop the smallest distance from the heap, and we will add all the nodes adjacent to the current node that we are popping. And we want to continue doing that until we reach node n-1. And then finally, we will return the minimum distance that is needed. So let's go over this example real quick. So just to remind again, the first value in the tuple for the heap would be distance, the second would be node, and the key will be U, and the values would be node V and the cost to get there. So first, we will start at 0. So we will add the distance it takes to get to these 2 nodes to the heap, and we will pop from this, add node 0 to visit. And now that we see that there's an option to go to node 2 or to go to node 1 with a weight of 3, but we see that 2 is the smallest distance, so we will choose to pop from this one. And since we are here, we will update the distance to 2, and then now we will have to look at where 2 can go to. So we see that we can come here with a total distance of 6, or we can go back to 0 with a total distance of 4. So we will add those 2 tuples to the heap and pop this one. And we also need to add node 2 to visit now that we have visited node 2. Now we see the smallest distance so far is 3, and that is to go from 0 to 1. So now we will look at that option now that we are here. So we will pop this node, update distance to 3, and add this node to visit. And then we need to calculate the distances here. So it will take a distance of 9 to travel back because 3 plus 6 would be 9. And to come here, it would be 5 because 3 plus 2 would be 5. So we add those 2 tuples to the heap, add node 1 to visit since we just visited, and distance is now 3. The smallest distance right now is 5. So we will look at this one, pop this one. And before we need to add the distances or anything, we realize that we are already at node -1 and the distance is 5. So we can return 5 as our result. And the time complexity would be O of E log V, where E is the number of edges and V is the number of vertices, because we will have to look through E number of edges, and each time we pop, the time would take log number of vertices time. And the space complexity would be O of E plus V, because the heap and this maps dictionary will depend on the number of edges and vertices. So now let's get to the coding part. So first we will create a default dictionary. We'll call it maps. So for U, V, W in edges, we will set mass of U and append VW. And when the key is V, we will append u and 2 times w. And now we will initialize the visit set, and we will set heap to 0, 0. Now while heap, we will set distance and u, and we will get that from popping the heap. Now if we are already at n-1, so if u is n-1, that means we have reached a destination, so we will return the distance. If not, then we want to check if we have visited that node. If it is, we continue. If not, make sure we add that to visit so we don't revisit again. Now we will look at all the nodes adjacent to u. So for v, w, and maps of u, then we would calculate the distance. We'll call it new distance. It will be distance plus w. And we will push that distance and node v to the heap. So heap push heap new distance v. And if we cannot reach the distance, we'll return -1. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.